Reclaiming an extra 8 hours every single day would rewrite the rules of human existence. In a world where the global economy never pauses, productivity would increase by a third overnight. But while eliminating the need to power down sounds like the ultimate competitive advantage, the biological reality would be fatal. Thomas Edison viewed sleep as a redundant heritage from our cave days. His incandescent light bulb provided the first practical tool to override the biological cycle and extend the working day deep into the night. Modern research shows that sleep is an aggressive state of maintenance. During slow-wave sleep, the glymphatic system activates. Brain cells physically shrink, expanding the space between them so cerebrospinal fluid can flush out metabolic waste products like amyloid beta and tau proteins. This nightly rinse accounts for the biological cost of neuroplasticity. Every memory formed or skill acquired during the day creates toxic byproducts that must be cleared to maintain cognitive health. Sleep acts as an essential custodial mechanism. Without this dedicated maintenance phase, the neurological system eventually drowns in its own waste. If the glymphatic system were permanently disabled starting tonight, the human body would undergo a rapid chronological breakdown. Within 24 hours, sleep pressure overrides standard cognitive function. Reaction times and decision-making degrade to levels equivalent to a blood alcohol concentration of 0.10%, past the legal limit for driving. After several days, the brain's emotional architecture dismantles. The amygdala becomes up to 60% more reactive to negative stimuli, while the prefrontal cortex loses its ability to enforce logical control over moods. Clinical evidence details this collapse. Sleep-deprived individuals exhibit severe irritability, a disregard for social conventions, and a sharp increase in impulsive, high-stakes risk-taking. The biological cause is a functional disconnect. The medial prefrontal cortex fails to regulate the amygdala. Without a nightly reset to stabilize this connectivity, the brain cannot process waking emotions, resulting in a state of permanent volatility. Over months, the damage becomes systemic. The immune system's natural killer cells diminish. Metabolic dysfunction leads to insulin resistance, and uncleared proteins accelerate the pathology of Alzheimer's disease. Without the mito-restorative phase of sleep, the body moves toward dementia, systemic disease, and cellular death. Sustaining 24-hour consciousness requires a bypass of standard human evolutionary limits. To avoid total collapse, the body must cheat the chemistry of fatigue. This bypass already functions in a small subset of the population carrying specific genetic mutations, such as a variant on the DEC2 gene. This trait is known as familial natural short sleep. These individuals consistently sleep only 4 to 6 hours a night. Despite this, they suffer no cognitive decline, maintain high energy levels, and display an unnatural resilience to neurodegeneration. Research suggests these brains are highly efficient waste managers. A mutant brain can clear the same volume of toxic aggregates in roughly half the time required by a standard human brain. These genetic outliers prove that human sleep requirements are a highly adjustable biological parameter rather than a fixed rule. Achieving true zero-hour consciousness would require scaling the efficiency of these short sleeper mutations until rest becomes unnecessary. The brain must perform glymphatic washing in real time. A steady, pulsing flow would clear metabolites during active wakefulness without interfering with neural signaling. A second adaptation would be required to replace the emotional processing currently handled by dreaming and REM sleep. The infralimbic cortex would have to generate constant theta frequency oscillations during the day. This frequency would actively suppress fear expression cells in the amygdala, regulating trauma and emotional charges on the fly. Achieving continuous consciousness requires severing the hardwired link between cognitive effort and fatigue, creating what would effectively be a new human species. If this evolutionary leap were scaled globally, the transition would trigger a total reorganization of modern society. The Rand Corporation has calculated that insufficient sleep currently costs major economies hundreds of billions of dollars in lost productivity. A sleepless society would eliminate these losses overnight. However, gaining 33% more life raises a sociological concern. We must ask if those extra hours would belong to the individual, or if corporations would simply demand a 16-hour workday as the new baseline. There is also the psychological toll of an unbroken stream of reality. Long before we mapped the brain's waste systems, Shakespeare described sleep as the primary healer of hurt minds. Sleep is our greatest physical vulnerability, yet it is the mechanism that preserves our sanity. If you could end the need for sleep, reclaiming decades of lost time at the cost of your nightly escape, would you take the pill?